Hello friends, in this video we are going to see about matrix concept and the various types of matrices. So what are the things which will be covered here is what is a matrix exactly, how to understand a matrix, and whether or how the types of matrices are used, in what cases each type of matrices are used. This is what this video will cover. It will not cover how to add two matrices, how to multiply two matrices, or how complex conjugates are involved in matrices. Complex conjugates are like if 1 plus I means 1 minus I is going to be its complex conjugate. That's the basic thing which is needed to known for the understanding this video. So next slide is an illustration to begin with. So what is a matrix? For that, an illustration from the book Algebra by Michael Artin. So we are considering the case where a candy bar is there with m ingredients. So let A denote the number of grams of ingredient I per bar, and a matrix A contain all the A elements. Bi denote the cost of ingredient I per gram, and let matrix B contain all the Ba elements. The matrix product AB computes the cost per bar, that is grams per bar multiplied by cost per gram is equal to cost per bar. So we will just see an example for this one. So variables have replaced the values have been given for the variables. So consider a candy bar containing 5 ingredients. Let A1, A2, A3, A4, A5 denote the number of grams of ingredient I per gram per bar, and a matrix A will represent all this AA information. B1, B2, B3, B4, B5 denote the cost of ingredient per gram. So one is denoting the number of grams, and the second thing, B matrix, is going to denote the cost of each ingredient. So next, the matrix product AB computes the cost per bar, like after adding each ingredient multiplied by the number of grams, which the quantity of the ingredient, we will get the cost per bar. So if A1 is equal to 5 grams per bar, B1 is equal to 2 rupees per gram, then A1 into B1 equal to 10 rupees per bar. So this is going to denote the cost of incorporating the first ingredient in the bar. So similarly, A2, A3, A4, A5. So this is how what the basic information is. This is like normally we will say, like if you buy 5 apples, what is the price? If one apple's price is going to be this, similar way only this thing is going to work. The matrix is going to work. It is a way of indication, and it allows why matrices means matrices allow us to multiply, do the addition, subtraction, all the various calculations which we do in linear algebra, we can do using matrices very easily. So when we do those operations, we will be able to get the result. That's why we are using matrices. And next slide is matrix definition. So matrix is, going by the definition, it is a rectangular array of numbers or other mathematical objects called the entries of the matrix. Matrices are subject to standard operations such as addition and multiplication. Most commonly, how the addition and multiplication will work is, if 2 by 3 matrix is going to be there, that is 2 rows and 3 columns matrix is going to be there, then if we add those 2 rows, if A is going to be 2 by 3 and B is going to be 2 by 3, we can add 2 by 3, A plus B. Whereas if B is going to be 3 by 2 and A is going to be 2 by 3, we cannot add A plus B. So such a thing is there. So this is how the matrix addition works. And the matrix multiplication will work when the number of columns in A matrix is going to equal to the number of rows in the B column. So that is the basic condition for in which the matrix multiplication is going to work. So matrices are subject to standard operations such as addition and multiplication. Most commonly, a matrix over a field F is a rectangular array of elements of F. A real matrix and a complex matrix are matrices whose entries are respectively real numbers or complex numbers. This is a very simple definition. So next, here just a small technical term has come. It is field F. So field F is a vast field, but we will just see the definition alone. In mathematics, a field is a set. It is a set on which addition, subtraction, multiplication and division are defined. It is just simply a set where these all the basic arithmetic operations are defined and behave as the corresponding operations on rational and real numbers. So an example of a field is a fundamental algebraic structure. Field is just a fundamental algebraic structure which is widely used in algebra, number theory, and many other areas of mathematics. The best known fields are the field of rational numbers, where if we multiply two rational numbers, we are going to get another rational number. If we are going to add two rational numbers, we are going to get another rational number. We are going to subtract two rational numbers similarly. So it is a set. Within that set, the elements should be contained. Whatever operations are going to be done, the elements should, after doing those operations, the elements should belong to the same set. It should not go to another set. The field of real numbers is also another field, and the field of complex numbers is another field. All three things we usually call as sets. Here the higher definition of those sets is fields. And next is determinant of the matrix. So determinant, usually those who are familiar with matrices will know determinant of a matrix is just we have to take one value and then there will be a process of calculation. So if you do the process of calculation, we will get the determinant of the matrix. That data will be available in Wikipedia, and previous slide also, all these definitions I have taken from Wikipedia. So determinant of the matrix, is it a mere number or there is more to it than meets the eye? So determinants exist for, it is like a volume of a parallelepiped when we take a 3x3 matrix. So here in the right there is an illustration which has been given. So there are three vectors is there, r1, r2 and r3. When r1 is added with r3, we get another edge. By graph theory, if we are going to say that is an edge, and if we are going to say r1 plus r2 plus r3 is going to be another area, another point, if we add all these three vectors, and r1 plus r2 is going to be 1. So when we see finally, after getting all the vertices or edges, when we connect all these vertices or edges, we get a parallelepiped. This is the volume of the parallelepiped is going to indicate the determinant of the matrix. This is what the determinant of the matrix is. This is the value. This value is going to indicate the determinant, whether the value is going to be positive or negative, based on the orientation of the parallelepiped, that is, which is preserved or reversed by the operation. If it is reversed, then it is negative. If it is preserved, then it is positive. And this is R3, the parallelepiped volume of the parallelepiped is R3, that is Euclidean space, R3, three-dimensional space. In R2, the absolute value is area of parallelogram. It is not the volume. So it is positive or negative based on whether the orientation of the parallelogram is preserved or reversed by that operation. So again, I have taken this reference from Wikipedia and the book Algebra by Michael Artin. Next, these are the types of matrices. So types of matrices are like various kinds of matrices are there. In simple terms, real matrices and complex matrices, as I saw previously. Here in detail, if you are going to see there is a square matrix, there is a rectangular matrix. Square matrix is going to be like a square, that is the values on rows and number of rows is going to equal to the number of columns. Rectangular matrix, it is not the case. If the number of rows is not equal to the number of columns, then it is a rectangular matrix. It will be like a rectangle. Unit matrix is going to have the diagonal elements as 1, and the diagonal matrix is going to have the other than its diagonal, other elements are going to be 0. So similar, the unit matrix is a special case of diagonal matrix because it has only 1 and the other elements are 0. Upper triangular matrix is going to have the elements along the diagonal and upper above it, it is going to have some values. Below the diagonal, there is not going to be any values. So that is upper triangular matrix. Lower triangular matrix is along the diagonal and below the diagonal, there are going to be values. Above the diagonal, the values are going to be 0. So 0 matrix is going to be completely a null matrix. There are no values are going to be there. Invertible matrix, any matrix which is going to have an inverse, then that matrix is going to be called as inverse matrix. How to find the inverse means, there is an identity matrix is there. Identity matrix is going to be like a unit matrix. If it is going to be like 2 by 2 matrix, it is going to be 1 0 0 1. that is going to be the identity matrix. If it is a 3 by 3 matrix, means along the diagonal it is going to be 1, and other than that other elements are going to be 0. That is also a unit matrix. So if we multiply one matrix and the other matrix and we get an unit matrix, then that other matrix is known as inverse of the first matrix. So if we are able to find out the inverse of the matrix, then that matrix is going to be called as an invertible matrix. And there is an Hermitian matrix and a skew Hermitian matrix. These two are matrices correspond to complex numbers. So we are, as a result, we are seeing the imaginary term in the matrices. So we will see about skew matrices, skew Hermitian and Hermitian in the next slide. So the other notes are like A plus B addition not possible, because in first case we have given square matrix as A and rectangular matrix as B. So as we saw, as I said previously, A plus B addition is not possible because the number of rows and number of columns are not matching in A and B. Number of rows of A is not equal to the number of rows of B. Number of columns in A is not equal to the number of columns of B. A into B multiplication is possible because A is 2 by 2 matrix and B is 2 by 3 matrix. The number of columns of A is 2, number of columns of B is number of rows of B is 2. So 2 and 2 after going we get 2 by 3 matrix, the number of rows in the first matrix and the number of columns in the second matrix. So we can multiply A by B, A and B, and we will get a 2 by 3 matrix. And it is not the case that A into B will equal to B into A. That is not the case. If we take B into A, B is going to be 2 by 3 matrix and A is going to be 2 by 2 matrix, and the number of columns in B is 3 and the number of rows in A is 2. So those two are not matching. As a result, we cannot multiply, we cannot get the value of BA, whereas we can get the value of A into B, but we cannot get the value of B into A. And upper triangular matrix can also be called as an row echelon form. So echelon matrix, we will call our upper triangular matrix, and those things are as a echelon form when it is going to have only the diagonal elements, and below, either below the diagonal or above the diagonal, the values are going to be 0. We will call the matrix is going to be in echelon form. Next, all these values were prepared using a text software, mathematical software, for illustration purpose. And next is symmetric and skew symmetric, and Hermitian and skew Hermitian. Like skew symmetric and skew symmetric is going to be for real numbers, and Hermitian and skew Hermitian is going to be for is an extension of symmetric, and it is going to be for complex numbers. So if in symmetric and skew symmetric, if we are going to have a matrix, when we matrix of transpose of a matrix is nothing but it will be denoted by A super on top of it AT. That is going to indicate the transpose of the matrix. A is the matrix, and A and superscript is going to be T. That is going to indicate the transpose of the matrix AT. So AT is going to have if the transpose of the matrix is taken and it is compared with the original matrix, then if those two matrices are going to match with each other, then it is a symmetric matrix. It is symmetric along the diagonal. So why we have to find out the transpose? The transpose, it is one way of knowing the data, how the data is going to work out for us. Whether it is we are one way of analyzing this data. So how we get the transpose of the matrix? We have to whatever there in the rows has to be put in the columns. A11 will stay in whatever is there in the along the diagonal will stay along the diagonal, and if A21 element A21 will belong to A12. That is element belonging to the second row and first column will go to the first row and second column. So similarly A31 will go to A13. A31 is third row first column element will go to the first row third column element. So in this way we do the transpose. So if A transpose is equals to A, then it is a symmetric matrix. If A transpose equals negative A, then it is known as a skew symmetric matrix. Hermitian matrix is when the transpose of a given complex matrix is taken. The transpose equals the conjugate of the matrix. when we take the transpose of a given complex matrix, the transpose equals the conjugate of the given matrix. That is, if it in the previous example, if we case here the right side we see towards the end we see Hermitian matrix. So Hermitian matrix is going to have 1 minus I 3 along the first row, and 1 plus I 3. When we transpose, what we get is 1 plus I 3 along the first row, and 1 minus I 3 along the first column. So if we get the matrix in this way, the 1 minus I is going to come here and 1 plus I is going to go there. So we are getting a complex conjugate. The 1 plus I's conjugate is 1 minus I. Similarly, I's conjugate is minus I. So when we transpose the matrix, in that position we are getting the negative the conjugate, that is negative element, negative imaginary number, and other elements, other numbers are real numbers. As a result, we are not bothered about it. So this is an Hermitian matrix. Next, if we see skew Hermitian, similarly it is a 2 by 2 matrix. It is very simple to understand. Minus I 2 plus I are along the first row, minus I minus 2 plus I is along the second row. So skew Hermitian, we will see the definition. So skew Hermitian is if it equals the negative conjugate of the given matrix. If we take a transpose of a matrix and if it equals the negative conjugate of the given matrix, then it is skew Hermitian. So like a skew symmetric, when we take the transpose of a matrix and we see that it is equals to the negative of the given matrix. Here, if we take the given matrix and take the transpose, if it equals the negative conjugate of the given matrix, then it is skew Hermitian. So minus I 2 plus I is going to be along the first row, the transpose, and the minus I minus 2 plus I is going to be along the first row, and the minus I 2 plus I is going to be along the first column. So when we take the negative out, we will see that A equals to minus A transpose. So this is skew Hermitian. So next, this is the end of this slide and video, and thanks a lot for watching. This is very basics in a fast way, in a brief manner. I just like to cover so that whoever like to refresh and whoever wanted to know in a fast manner, they can watch this video, and I thought like it will be very helpful. I hope you find it helpful. Thanks a lot for watching.